Welcome back. In this lecture, we are going to understand about Terraform backend remote state storage. So what is a Terraform backend? On a very high level, backends are responsible for storing state and then providing an API for state locking. So that is what called the Terraform backend. In detail about the Terraform backend and how many types of Terraform backends are there, all those things after this introductory lecture, after we implement the remote state storage in a detailed manner with a practical demo, we will learn about those things. Okay, so that's a theory part we'll put at the end of the demo. So once the demo is completed and this introductory part is completed, so we'll read that or understand about those theory parts after these two lectures or these two sections. Okay, so now moving on, so we have two things here from Terraform backend perspective. So one is Terraform state storage and another one is Terraform state locking. Okay, so for Terraform state storage, when you are using the AWS as the provider, so we will use the AWS S3 bucket, which means our terraform.tf state file will be storing in AWS S3 bucket. In the same way, for implementing the state locking, we will be using the DynamoDB table from AWS. So we'll understand about state locking a little bit later, but for now, these two are the AWS services we are going to use for state storage and then state locking. Let's move on. Okay, so let's understand about what is the problem with the local state file and how we are going to resolve it with remote state file. So let's start with, you are a admin, you can call it as admin1, and he has his own admin desktop, right? So there what he does is using Terraform, so he'll go ahead and then provision a EC2 instance, and then whenever you do the Terraform apply, immediately terraform.tf state file will be created in your local working directory of your admin1 desktop. So now here comes the problem of admin2 and then admin3 of your respective organization also planning to manage this infrastructure. So if you see here, they really don't have access to your own desktop, in your own desktop and in the local working directory where you have the terraform.tf state file. But to administrate this infrastructure, whatever you have provisioned, right? So they need the access to this terraform.tf state file. Then only they can do anything. But it is in your local desktop, they can't do anything. So multiple team members cannot update the infrastructure as they don't have access to the state file. So that is the problem when you use the local state file, right? So what should be the solution, right? This means we need to store the state file in a shared location. So from local state file, you need to move to remote state file, for the reason that every team member of my team will be able to administer my infrastructure. They need to have access to the terraform.tf state file. Okay, fine. So using Terraform backend concept, so we can use AWS S3 as the shared storage for state files. Okay, so using the Terraform backend concept, we'll use the AWS S3 for shared storage. Okay, fine. So now let's see. As admin1, from admin1 desktop, I have access to the AWS S3 bucket where the terraform.tf state file is located. So I can administer the EC2 instance, whatever I have provisioned using earlier with this terraform.tf state, because I have the entire access for me. So now here starts. So admin2 also will have the access to the S3 bucket where the terraform.tf state file is present. So he will be able to do that. In the same way for admin3 also. So which means now once you share your terraform.tf state file in a shared location like S3 bucket, so every administrator will be able to administer your respective cloud environments, whatever you have provisioned. Okay, this is good. But what next, right? So there will be one more problem with even using the remote state file. Example, like if two team members are running the Terraform at the same time. So admin1 and then admin2 executing Terraform apply at the same time, and the updates are going to take place in your infrastructure accordingly. You may run into race conditions as multiple Terraform processes make concurrent updates to the state file, okay, which leads to conflicts, data loss and state file corruption. So this is another problem you are going to have when you move from local state file to remote state file. So let's see how you are going to resolve that too. So you are going to resolve that using implementing the state locking functionality. So what does this state locking functionality mean, right? So let's see that here. Okay, so as admin 1, admin 2 and then admin 3 are accessing in the same terraform.tf state file from the S3 bucket, and then they are able to provision. So we will also implement something called DynamoDB table. So we'll create a DynamoDB table and we will reference this respective DynamoDB table in our Terraform backend. We are going to see what exactly the Terraform backend configuration going to be in our next slide. So for now, for Terraform state storage we are using S3 bucket, and for state locking we are using DynamoDB. So now at any point of time, if admin 1 tries to provision or change the infrastructure using Terraform, so this terraform.tf state file will be in the lock state. Okay, so whenever you run Terraform plan or Terraform apply, so first it will lock it, and then once it is locked, then it will perform the changes, and then after that again it will release the lock, which means at the same time if admin 2 or admin 3 tries to access the terraform.tf state, so it will not be accessible for them, or it will not be allowed by them to provision any changes. Okay, so that's the check we are going to enable using DynamoDB table. So now let's understand a little bit about these things. Okay, so not all backends support state locking. So let's understand more about this state locking. So in all the backends, whatever Terraform supports, right? So not that every backend should support state locking. So few backends will also not support the state locking. With that said, AWS S3 supports state locking. That is the reason we are using it. And next thing is, state locking happens automatically on all operations that could write state. Okay, so whatever the operations are nothing but the Terraform commands. Okay, so Terraform plan, Terraform apply, or Terraform destroy. So example, on a very high level, let's consider you are running Terraform apply. Okay, so Terraform apply operation will write the state whatever the changes happen, or Terraform destroy operation also will write the state. Okay, so whatever the things destroyed, it will be updated in the terraform.tf state file. So in these two operations, obviously state locking will be enabled. Okay, so that's about it. And next thing is, if state locking fails, Terraform will not continue. Okay, so that is another important thing. And once you enable state locking, you get that benefit. So you can disable state locking for most of the commands with the -lock flag, but it is not recommended. If acquiring the lock is taking longer than expected, Terraform will output a status message. If Terraform doesn't output a status message, state locking is still occurring if your backend supports it. And another thing here is, Terraform has a force unlock command to manually unlock the state if unlocking failed, which is a non-recommended option. But if there is no other way, then you can use this force unlock command. Now the next thing here is, whatever the Terraform block going to look like in C1 versions.tf. So earlier we have only this part, required version and then required provider. Okay, but now we also added the backend part. Okay, so in the backend, which is nothing but the Terraform backend, so we are adding the backend type is S3, and we are providing the bucket name, S3 bucket name, and also the key. Key is nothing but in which folder path and what would be my terraform.tf state file name. So you can give dev.tf state or qa.tf state, whatever you want, and also provide the region. So these three parameters are used to do the Terraform state storage to remote backend. So that's important thing here. Okay, and next thing is, provide the DynamoDB table name. Okay, for state locking. So this second part is for Terraform state locking. Okay, so this completes the high level introduction of state file with the state locking. So storing the remote state file in the remote storage, and also state locking. So in our next lecture, we are going to look into the demo, and once the demo things are completed for remote state storage and then state locking, so we'll move on and then understand more about a theoretical concept of backends and what all important things we need to learn. So I'll see you in the next lecture. Until then, bye bye. Thank you.